All right, guys, we're going to get into the 2.5 notes that we need to do for this unit here. And again, I apologize that I'm not able to be at school for these. But I need you to find next clean sheet of paper in your notebook and label this 2.5. And today we're just going to build on 2.4, and we're just going to talk about systems of linear inequalities. And then date today is the 20th if you'd like to add that. All right, so last time we talked about linear inequalities where we would have something in the form of y equals mx plus b, except with greater than or less than, and then I would graph it and I would shade one side or the other. So now we're going to talk about systems of linear inequalities. A system of linear inequalities is simply just two or more linear inequalities. System just means two or more linear inequalities. So for example, we could see something like this where I see y is greater than some numbers, so 3x plus 4, y is less than or equal to negative 2x plus something, doesn't matter. Okay, so this is what we're going to start to see, is we're going to see two different linear inequalities now. The solutions for these are similar to what we talked about in 2.4. The solutions to these are any x, y coordinates, okay, any x, y coordinates that make both inequalities true. Okay, that make both inequalities true. So last time we were only looking at one, and we had x and y coordinates that would work for one. Now they need to make both inequalities true. So for example, let's say I had a system of inequalities that looks like this. Y is less than 2x minus 3, and y is greater than negative 2x plus 2. Okay, and you can pause your video and write that down if you need to. So let's say I want to test and see if these points are solutions. So what I would do is I would take the x coordinate and plug it in for x, and the y coordinate and plug it in for y, and I would take this one inequality at a time. So I'm going to start with the first inequality here. I'll plug in negative 3 for y, and I'll plug in 1 for x. So that is what this would look like. And then I will check and see if this gives me a true statement. So it's a negative 3 is less than, I could multiply 2 times 1 to give me 2, and then minus 3. And then negative 3 is less than 2 minus 3, which is negative 1. So ask yourself, is negative 3 less than negative 1? It is, so it does work for the first inequality, but now I need to check and see if it works for the second inequality. So I'm going to do the same thing. I'm going to plug in negative 3 into that inequality for y, and I'm going to plug in 1 into this inequality for x. So if I plug it in, it would say negative 3 is greater than negative 2 times 1 plus 2. Then I would simplify this expression, so negative 3 is greater than negative 2 times 1 is simply just negative 2. And then I would try to simplify this just a touch more. Negative 3 is greater than negative 2 plus 2, which is 0. So I get to the end and it says negative 3 is greater than 0. So I can ask myself, is that true? No, that is not true. Negative 3 is definitely not greater than 0. So I would say this point right here is not a solution. Okay, I can do the same thing with the other point here as well. So starting over, let's say we have 4 comma 1. I would take the y value of that and plug it in for y into the first inequality. So 1 is less than 2 times 4 minus 3. And then I would simplify this. So 1 is less than 2 times 4 is 8 minus 3. So 1 is less than 8 minus 3, which is 5. Is that a true statement? That is. So I know it works for the first inequality. Now I'm going to check the second one. So plugging in 1 for y again. So 1 is greater than, and then negative 2 times 4 plus 2. Let's check this one as well. 1 is greater than negative 2 times 4 is negative 8 plus 2. So 1 is greater than negative 8 plus 2, which is negative 6. So same question, is 1 greater than negative 6? It is. So since it works for the first and it works for a second, this point right here would be considered a solution. So this is how I would check individually, point by point, if something is a solution to the entire system or not, and it would have to work for the first and the second. However, I can also show this on a graph, and I can show all the coordinate points that are solutions for one, are solutions for another, or more importantly, are solutions for both of them. And that's the points that I'm interested to know. So let's kind of build on what we talked about on 2.4, where I want to graph these and see which direction I need to shade. So I'm going to do the same thing as 2.4. I'll go ahead and graph or sketch a little 5x5 graph here. Same as always, the graphs will be given to you on your assignment, and the sub should have that. So I'll go ahead and draw these in here. And we'll use the same process that we have been multiple times now. We'll start off by graphing these lines by graphing the y-intercept. So on the first inequality, I'm just looking at this one, the y-intercept is -1. So I'm going to plot a point at -1 here. And then I'm going to use my slope, which is 2. Or if it's written as a fraction, I could write it as 2/1 if I'd like. So that's telling me to go up 2 and right 1 and plot a point. And then I can continue that pattern up to right 1, up to right 1. Same idea here, down to left 1, going the other direction, down to left 1, going the other direction here. And as a reminder, I don't want to get in the habit of just drawing the line like we usually do, because the symbol might tell us to do something different. So the symbol right here, if I look at that first inequality, is just the greater than symbol. If I just see that symbol, I actually want to use that table from 2.4, and I want to draw a dotted line, which means all the points on this line are not solutions. And then last thing I need to decide here is I need to decide whether to shade in above the line or below the line. In this case, it is the greater than symbol, so I would shade everything above this line. And what I'm going to do on these, that's slightly different from 2.4, is I'm just going to lightly shade it in. And I'll explain why we do that after this next one. Okay, but I'll lightly shade it in. All right, same process with the second one here. So start off with your y-intercept, which is at +2. I'll draw this in a different color for you guys so you can see this a little bit clearer. Starting off with +2, so on the y-axis, +2. And then my slope is -1/2. Remember, it's negative, so it should go down and to the right. So it's telling me to go down 1, right 2, plot a point. Down 1, right 2, plot a point. Same thing the other direction, up 1, left 2, up 1, left 2, and I can plot a point here. Be careful when you draw your line as well, make sure you're drawing the correct type of line. If I see the or equal to on my symbol, then that means I am good to go ahead and just draw a solid line, which I will do here. So I'll draw this solid line, and now I want to shade as well, just like we did in unit 4, or I'm sorry, 2.4. So it is the less than symbol, so I want to shade everything below the line. And again, I will kind of shade this lightly here. So all I'm doing is paying attention to the red line. I'm just lightly shading everything below it. Okay, what I'm looking for on these kinds of problems is I want to show the solutions that work for the first one and for the second one. The place or the coordinates that work for both of them is where the two shaded regions overlap. So these two shaded regions that's above the green line and below the red line would be right here. So this is what I want you to do, and this is why I shaded lightly, is because my final answer needs to look something like this. The darker shaded region is where all of my solutions are located. Some in the other regions work for one or work for one of the other inequalities, but the darker shaded region is where all my solutions are located because they work for the first and the second one. Okay? We can also practice this with different types of looking inequalities here. So same kind of idea. Let's say I had this system of inequalities now, and you could go ahead and write that down. I'll draw another graph for this one, just so we have something to go off of as we're working on the problems for today. And so let's take this one at a time. The first one is not in slope-intercept form, so I want to make sure to get it in that form. I'm just going to write this over to the side so I have some space here. So remember, in order to do that, we want to get y by itself. So I would start off by subtracting x from both sides. When I do that, these would cancel, and I'd be left with -y. I would have the greater than or equal to symbol, and then as we've talked about a lot, you cannot combine this number and this variable, so I would just write it with the x term first. So -x and then +4 since it's a +4. And then I'm almost done, but I still don't have y by itself, so the last thing I need to do is get rid of the negative by dividing by everything by -1. So when I do that, these cancel, leaving me with y. And then as a reminder, dividing by -1 just changes the value, or changes the sign in the value. So -x turns into a +x, +4 turns into -4. And that rule still applies that we've talked about with inequalities. We divide it by a negative number, so we flip the symbol. Okay, don't forget to do that. So this is our new first equation, is y is less than or equal to x minus 4. So I'll use that same process. I'll plot our y-intercept of -4, and then my slope is 1 here, or 1 over 1 is a fraction. So go up 1, right 1, and plot a point, and then just continue that same pattern as much as you can on the graph. I can also go the opposite direction, down 1 and left 1. All right, I want to make sure I draw in the correct line here. This is the less than or equal to symbol. The or equal to tells me that I can draw a solid line. The solid line tells me that every point on the line itself is a solution. And then lastly, I do want to shade as well. This is the less than or equal to symbol, so I would shade everything below this line. And again, on these kinds of problems today, I'll get in the habit of just shading in lightly. All right, that is our first inequality. The second inequality here looks very different. It is x is greater than 2. If you see some inequality with just x or just y, it means you're either going to have a vertical line going up and down or a horizontal line going left and right. Here, if it's just x is greater than something, that would be a vertical line. So I'm going to go on the x-axis. I'm going to find where positive 2 at, which is right here. And I'm going to draw in a line. And notice it's just the greater than symbol. And so I would actually draw in a dashed line right here. So we've talked about that before. If you just see the symbol, that's a dashed line. So I want to draw a dashed vertical line. And then this last part here, I do want to shade as well. Unfortunately, I can't shade above or below this line. So instead, I just need to figure out where these values are located. All the values that are greater than positive 2 are all to the right of it. So I'm going to shade lightly everything to the right of this line. Okay, and sorry, I could have done that in a different color as well if it helped. Oh, and I need to make this a dashed line as well. So my second line here, x is greater than 2, it would look like this. And my shading would be over here, everything to the right of it. Okay, I'm ignoring the first line right now. All right, so final answer, I need to make sure I have a region that is shaded darker than everything else, and that is where my two shaded regions overlap. So everything to the right of the red line and below the green line would be right in here. So this is what I'd be looking for your final answer. This is where all of your solutions would be located. Everything outside of it would not be solutions, at least not for both of these inequalities. All right, last thing here, you could also try to put yourself to the test. Let's say I gave you a graph and you wanted to try to figure out what the inequalities were that matched them. So I'll try to use, as best I can, the colors that are denoted here. So if I wanted to actually show what these inequalities were, you could try to pause the video and figure these out one by one. So the orange line, it looks like it has a y-intercept of positive 2, so I know it would be something with plus 2. Looks like it has a slope of 1, so that would be 1x. I know I have y in here. It is a solid line, so it would be or equal to, and everything below it is shaded. So this would be y is less than or equal to 1x plus 2. That would be how I draw or write the equation for that first one. And then the second one here, the blue line, that is a dashed line. It does have a y-intercept of 0, so if I wanted to write this, I could write plus 0. It looks like it has a slope, if I can find this here, I believe it has a slope of a rise of -1 and a run of positive 3, so the slope would be -1 over 3. So this would be -1/3 x here. I would also have y on the other side. Everything below this line is shaded, so it is less than, and it is a dotted line, so it is just the less than symbol. So if you were asked to identify what the inequalities were that match this graph, that is what those inequalities would be here. Okay, that is the notes for today. Rest of time you can be working on the 2.5 practice. This will be due next Tuesday when I get back. If you have any questions, just hold on to them and try to use this video as a resource, and then otherwise I will answer anything when I come back.